Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x plus 3 is equal to 3 to the power of x plus 2. And we want to find our value of x here. So the first thing we are going to do is we are going to divide both sides by, well, before that actually, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, we have 2 to the power of x plus 3 and 3 to the power of x plus 2. 2 to the power of x plus 3, this would equal 2 to the power of x times 2 to the power of 3. 3 to the power of x plus 2, this is going to equal 3 to the power of x times 3 squared. Now I'm going to divide both sides by 2 to the power of 3, as well as 3 to the power of x. So now I have 2 to the power of x over 3 to the power of x because these two cancel out. And for my right hand side, these two cancel out, so I'll have 3 squared over 2 to the power of 3. Alright, so now if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 2 to the power of x over 3 to the power of x, this is going to equal 2 over 3 to the power of x. And now I'm not going to do anything to this. This will still remain 3 squared over 2 to the power of 3. So now what I'm going to do is I'm going to take the log on both sides. So now I have log 2 over 3 to the power of x is equal to log 3 squared over 2 to the power of 3. And if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So for log 2 over 3 to the power of x, I'm going to use this property and move my exponent here, x, to the front of the logarithm. So now I'm going to have x times log 2 over 3 is equal to log 3 squared over 2 to the power of 3. Now I'm going to divide both sides by log 2 over 3. So then these two cancel out, and I have x is equal to log 3 squared over 2 to the power of 3 divided by log 2 over 3. Now if I have something in the form log a over b, this is equal to log a minus log b. So for log 3 squared over 2 to the power of 3, this will equal log 3 squared minus log 2 to the power of 3. And for log 2 over 3, it's going to equal log 2 minus log 3. Now remember the property that states if I have something in the form log a to the power of b, this is equal to b times log a. So I'm going to use this property for both log 3 squared and log 2 to the power of 3. So I'm going to move my exponent to the front of the logarithm. So now I have x is equal to 2 times log 3 minus 3 times log 2 divided by log 2 minus log 3. Now, log 3, this is equal to 0.4771. And log 2, this is equal to 0.301. So now I have x is equal to, if I substitute in the values for 0.4771 and 0.301, I get 2 times 0.4771 minus 3 times 0.301, and I'm dividing this by 0.301 minus 0.4771. Now 2 times 0.4771 is 0.9542 minus, now 3 times 0.301 is 0.903. Now I'm going to divide this by 0.301 minus 0.4771 is negative 0.1761. And this is equal to 0.0512 over negative 0.1761. So finally, x is equal to approximately negative 0.2907. Now, to check, I'm going to plug in the value for x into the original equation. So I have 2 to the power of x plus 3 is equal to 3 to the power of x plus 2. And remember, x is equal to negative 0.2907. So now I have 2 to the power of negative 0.2907, which is equal to 3 to the power of negative 0.2907. And I forgot the plus 3 and plus 2. So now negative 0.2907 plus 3, that's going to equal 2.7093. And negative 0.2907 plus 2, that is equal to 1.7093. So now, if you plug this into a calculator, you get 0.5400, which is equal to approximately 0.5394. And these two round up to each other. So 6.54 is equal to 6.54, and because this is right, our solution is right as well. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x is equal to 5 to the power of x plus 2. So we want to find the value of x. So now, from our equation here, the first thing I'm going to do is, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 5 to the power of x plus 2, that is going to equal 5 to the power of x times 5 to the power of 2. And now what I'm going to do is I'm going to divide both sides by 5 to the power of x. So now I have 2 to the power of x over 5 to the power of x is equal to, these two cancel out, 5 squared. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, I have 2 to the power of x over 5 to the power of x, and we can think of a as 2 and b as 5 in this case, and x as m. So now I have a over b, so 2 over 5 to the power of m, so x in this case. And this is equal to 5 squared. Now what I'm going to do is I'm going to take the log on both sides. So now I have log 2 over 5 to the power of x is equal to log 5 squared. Now, because I took the log, I can use an important property of logarithms, which states that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm, so this would equal b times log a. So in this case, log 2 over 5 to the power of x, I can move this exponent x to the front of the logarithm, so this would equal x times log 2 over 5. This is equal to, I'm going to do the same thing with log 5 squared. I'm going to move my exponent to the front, so I'll have 2 times log 5. So now I'm going to divide both sides by log 2 over 5. So then these two will cancel out. Now I'll be left with x is equal to 2 times log 5 over log 2 over 5. Now, if I have something in the form log a over b, this is equal to log a minus log b. So in this case, a is equal to 2 and b is equal to 5. So log 2 over 5 here, this would equal log 2 minus log 5. Now, log 5, this is equal to 0.6990. And log 2, this is equal to 0.3010. So now if I substitute these values in for log 5 and log 2, I get x is equal to 2 times 0.6990 over log 2 minus log 5, so 0.3010 minus 0.6990. Now, 2 times 0.6990, that is going to be equal to approximately 1.3980. And now we are dividing this by 0.3010 minus 0.6990, and this is going to be equal to approximately negative 0.3980. And now, if you divide these two, this is going to equal negative 3.5126. So x here is equal to negative 3.5126. Now, we are going to check this value of x. So, to check, our original equation, remember, which is right here, is 2 to the power of x is equal to 5 to the power of x plus 2. So this here was our original equation. Now, x here, this is equal to negative 3.5126. So we found our value of x. So now I'm going to plug in the value of x into our original equation. So now I have 2 to the power of x, so 2 to the power of negative 3.5126 is equal to 5 to the power of x plus 2. So 5 to the power of negative 3.5126 plus 2. Now, 2 to the power of negative 3.5126, this here is equal to 0.0876. And now 5 to the power of negative 3.5126 plus 2 is equal to 5 to the power of negative 1.5126. Now this is equal to 0.0876, which is equal to, now 5 to the power of negative 1.5126 is equal to 0.0876 approximately. And because both of these values are equally to each other, we can write LHS and RHS. This means that the left-hand side is equal to the right-hand side. And because this is true, we know that our value of x is right.